everyone. Welcome to the latest edition of the Cloud Native Now podcast. I'm your host, Mike Vizard. Today we have a guest. Viren Baraiya is the CTO for Orkes, and we're going to be talking about, how AI agents and orchestration and microservices is all going to come together because they're on a collision course. It's just a question of when now. Hey, Viren, welcome to the show.
Hey, thanks. Thanks for having me here.
As we've seen so far, microservices are not easy to build and maintain. A lot of folks are challenged by it. And as a result, they sometimes even go back to monolithic applications. We are seeing, though, the rise of these AI agents that are increasingly starting to be able to take on more complex tasks. I guess the issue is, how would we manage all these AI agents and create something that feels like some order in what could be a potentially chaotic scenario, and apply that to microservices? So you're at the forefront of this. What's going on?
Yeah, I think that's a great question, first of all. And I mean, if you kind of look back and think about it, right, there are a lot of similarities as well. Like when we look back and look at the microservices world, what started to happen was, people started building microservices, single responsibility functions. And once you had a host of microservices available in your kind of infrastructure, the next question came was that, okay, how am I going to manage all of those things? How am I going to essentially put all of them together to achieve my business goals? And what we are starting to see with the AI agents is kind of a similar story, that, the agent is only as good as the tools it has and the autonomy you give it to them, right? Otherwise, essentially, you are not really solving the fundamental problem in terms of how they are able to plan, execute, and deliver the results that you want. So I think the way I at least see is, a lot of learnings that we had with microservices, you can potentially apply them to how you build agents, how you operate and run them. And I think there are two critical pieces there, right? One is visibility into, what is happening. ML explainability has been a subject of research for quite some time. With the adoption and a broader adoption of AI and especially LLMs, it has even gotten a little bit more mainstream. Just imagine a case where you are leveraging AI agents which are making fully autonomous decisions. How do you get visibility into why that decision was taken? And we are starting to see some, kind of news about agents doing things that doesn't make sense, or, got company into hot soup and things like that. So this is where I think, the learnings from microservices in terms of it's not just about kind of how you put things together, but more importantly, understanding why it did that, being able to get visibility into it and be able to kind of do that in a safe way is going to be very critical. And I think there's a lot to learn from, the adoption of microservices, how it evolved, how it matured, and apply them to, agents.
And in a lot of sense with microservices, one of the things about it is that it creates redundant paths for API calls, so the application is more resilient. And in a similar way, we may have to route different tasks around the different AI agents, many of which may be checking on each other to ensure that the quality of the overall application or whatever route we're building doesn't go off the rails.
Yeah, absolutely. And I think I would say, in microservices world, you had the concept of edging, where you would send the same request to two different API endpoints, so that if one of them is slow to respond or is not available, your overall request still continues to operate. And I think you could apply, and we are starting to see that as well, right? With the AI agent as well, that, you are sending the same request to two different models, and maybe using a human to evaluate the response, or using a third model to again evaluate the response before actually responding back, right? And leveraging that kind of patterns to kind of put some more safeguards, some more checks and balances. And sometimes it's purely for evaluation. If you build a new model and you want to test it out before kind of rolling it out, you are kind of sending a shadow set of requests over there, evaluating them. And once you are confident, switching that path. And especially the way models are evolving, we are seeing a new version coming up pretty much every year. Oftentimes what was working in the previous version, the behavior changes. So, upgrading to the newer version also requires testing. And the biggest problem with AI and language models is that they are non-deterministic, which means you can't really have a set of use cases and say, oh, I'm going to run through this set of use cases, do a QA testing, and if they all pass, it's all good to go. That may not apply here. So now you have to kind of do this in production environment with real world, user inputs. So this becomes even more critical to be able to orchestrate the requests across different agents, different versions of the same agent, and things like that. Yeah.
So I may have agents that help me write code, and then I'll have an agent that helps me test, and then there'll probably be a set of agents that are doing security reviews and governance management kind of tasks. What will be the role of the human developer in all of that? How will they kind of be involved? Software engineers will orchestrate this using what?
That's a great question. What are we going to do if AI does everything? I think the more important thing there is somebody has to still kind of figure out how these agents are going to orchestrate the task amongst each other. Also be able to kind of do that in a safe way, which means there is going to be some human overview intervention required every now and then. I think that's one, and this kind of brilliantly applies to software development, for example, right? Like, a lot of software developers today are using copilots to write code, but they are still responsible to ensure that the code that is written kind of matches the requirement. It is safe to run. There are no bugs, and like a lot of people are also using AI to kind of generate automated tests. But somebody is still kind of orchestrating all of those things. I don't think we are there yet where we can say that everything is going to happen by AI automatically. And I think, essentially, we are shipping ourselves slightly at a higher order in terms of what we deliver as a value, which is what we are best at it, right? Being able to understand the business, being able to find the right set of agents to orchestrate, and where and how we orchestrate. I think that's the field that I feel like, is not fully developed yet. That's one area where I think Orkes, what we are working on is going to be very critical in terms of, you have all of these agents, you need a runtime for this agent so that you can run them safely. You can inspect, visualize, log them, and see what's going on, right? That's I think one area where I see a lot of opportunities and a need.
So, in effect, the AI agents still need a boss, and that would be called us, right?
Yeah. The right bit of it.
One of the things you see in microservices applications is there's just a lot of containers coming and going. And if you listen to folks, we might be building more software in the next few years than we built in the past decade. And so are we prepared to deal with the amount of ripping and replacing of containers that we're going to see at that level of scale? Because, well, we can't throw more bodies at the equation. So we got to find a way to kind of keep track of these containers that might only live for, 30 seconds?
Yeah. I think, yeah. And I think this is where the orchestration plays a very critical role, because you need a system that has a complete overview of what's going on. Because let's imagine a case where somebody starts spinning off containers, and you end up spinning thousands of containers, and you have no checks and balances, and you will find out when you get your next cloud bill. So that's definitely kind of the case. So, this is where the orchestration systems which are essentially responsible and have kind of right set of limits and checks and balances in place becomes more critical to understand, what's happening with my system. And I think, as you rightly pointed out, right, it is going to become easier to write a lot of code, build a lot of systems, where we will start to see is how well are you able to run this. So runtime aspect of it is going to be a lot more critical now than ever, because we can just do a lot more now.
It also seems to me, at least, that we're reaching a level of complexity, and maybe we're already there and we're just struggling with it, that the application environment is just too difficult for humans to manage by themselves.
I think we are already there. Like, even if you take the AI out of the equation, applications are complex. And especially as you kind of move things over to the cloud in a more distributed world, applications are increasingly complex in terms of its interconnectivity to other applications, different systems, microservices, events that are kind of being exchanged across different applications. So things are definitely a lot more complex. There is no longer the case where your application is a very simple, you have a database, you have a form, and somebody fills out the forms and saves in your database, right? That typically never tends to be the case. Now there's a lot more kind of business logic that is implemented. There's a lot of orchestration that is happening across multiple applications, including third-party systems and vendors. So they are definitely a lot more complex. And guess what happens when you have a very complex systems? It becomes increasingly complex and difficult when there are failures or things that you have to reason about as to why certain things happen, right? It doesn't have to be necessarily failures only. I would give you an example of a system that takes some decisions, right? Why did it arrive at a particular decision? You need to be able to know the entire graph of steps it executed to understand why it arrived at that decision. Now, if I were to build that graph in my mind, that's a lot more cognitive overload, the amount of time it takes. And that's where, orchestration systems like Conductor and Orkes becomes very critical, where you are able to understand what is happening, why it is happening, and if there are failures, be able to kind of, first of all, resolve the failures automatically, and if not, be able to kind of have a simple API call or a one-click button to resolve them. But yes, they in summary, they are already complex.
On the opposite end of that, are we in danger of becoming maybe too dependent on AI, and we let the machines kind of figure out everything that can be done, and we may not understand how it was done? And then when somebody calls us up, like a compliance auditor, and says, "Can you explain this?" we may not be able to.
I think that's an extremely valid point, and I hear that a lot, and this is one of the common themes that I kind of also hear from our customers, the users that I have spoken to is, yes, AI is great, but I need to be able to explain the decisions it took. And this is where I believe that, being able to explain the decisions that AI made is going to be extremely critical, non-negotiable in some sense, or especially in some industries, where you have to be able to justify and understand why that decision was taken. So, instead of AI becoming a black box, the way I would kind of think about it is that, if we are starting to see, and that is one area where we also kind of position ourselves is, you think about AI as tools that can help you automate things and take automated decisions, but you are still in control, and you have to have the complete visibility into, why this happened, what was the input given to it, what were the rationale, and maybe have a parallel kind of execution made to another model or an algorithm to validate that, even if I use a different AI system or an algorithm, I would arrive at the same situation. So now, when my compliance officer calls me and says, why did you do this? I have the full explainability as to why.
Do you think we'll also be able to use that capability to a degree to determine what is causing a performance degradation in my application? Because one of the issues with microservices is, well, they may not necessarily completely fall over the way a monolithic app will. I can spend a long time trying to figure out what it is that is causing a certain performance issue. And the maddening thing about it is, it might take me 2 days to figure that out, and it's about a 30-second fix.
Oh, yes, absolutely. And I think this has been kind of already, you might already see some of these systems similar to that, right? Like doing auto tuning. So, you put an AI agent or as a sidecar in your application deployment, which is constantly monitoring how your application is performing, checking logs and other systems, CPU memory, and kind of understanding, the application behavior. And in today's world, it could start with giving recommendations, but I can totally see in the future world, and I have seen those systems at play as well at large companies like Google, where it will just automatically tune it for you to the best of its capabilities. So, and the whole idea is, if you think about it, right, where we are best as humans is be able to understand the business, implement the business logic, and drive the business forward. everything that we have to do on the infrastructure side, how do I run my application? How do I get visibility to my application? As you mentioned, I tune my code for performance and everything. That can be very well done by machines and AI. So you kind of coexist and leverage them as your tools rather than think about it as kind of replacement. Makes you more productive.
How will the software engineering teams be organized? Because in my mind, it looks like we're going to have a small army of AI agents and working alongside humans, but it still takes a team of folks to build something. So how will the AI agents that I created work with the AI agents you created?
I think that's an interesting question. I would, I don't think I have the kind of answer that because right now it's such a nascent field. And we are starting and we are seeing frameworks, right? Frameworks like, for example, Conductor, where we are allowing people to kind of orchestrate across multiple agents through API calls. There are frameworks like AutoGen that allows you to kind of do the same thing where you can have conversational AI agents talking to each other and to achieve a goal or collaborate on a particular task and things like that. But I think that's another field that is evolving quite rapidly, and we will start to see maybe some amount of convergence there in terms of frameworks and how those things are kind of managed. And yeah.
You mentioned the Netflix framework that you guys are using at the base of your approach, but I'm trying to figure out where the cart and the horse is here, because sometimes I think people are going to try to create all these AI agents and then kind of add the framework to kind of manage it after the fact. So maybe we should be putting the frameworks in first and then figuring out what's going to attach to them second.
Maybe, but I mean, then I think it's the kind of dilemma, right? In terms of like, where do you invest and focus your time on, right? Building infrastructure is always more expensive, tricky. It requires very specialized skills overall. AI agents, fortunately, what has happened over the last few years is they have become almost commoditized, right? Like, you have a plethora of choices in terms of the models, their cost. So it's much easier to use them to build a POC, or at least put together a simple business use case, which is what everybody is doing today. Where I think, as you rightly pointed out, is there's a need for an infrastructure. There's a need for a runtime for all of these things, which does not exist yet outside of few kind of initiatives like ours. But I would say, as people kind of realize and try to find out, they will both converge eventually, as in pretty soon, probably.
Do you think ultimately, we hear a lot about the phrase platform engineering, and I wonder if this transition to AI agents is going to force us down that path? More organizations are going to have some centralized approach. But I guess one of the joys of DevOps was that, we embraced it in the first place so we could get out from underneath centralized IT. And so how do we strike a balance?
I think platform engineering is going to be the commonplace. And if not already, we are already seeing a lot more emphasis on platform engineering. And if you think about it, right, like you take your developers who understands business, who is able to kind of implement complex business solutions. You take AI, who is able to kind of take care of heavy, undifferentiated kind of work, like, helping them write code and things like that. Then what's missing part there is that platform where they can all put everything together and run it, so that now they don't have to worry about kind of that. So in some sense, I think, it's a complementary thing. And, when you put all these three things together, you get the most efficient, what I would like to call it, like, a 10x developers, right? 10x developers are less about developers and more about the frameworks and platforms that they operate on.
Clearly, we're kind of at some sort of crossroads when it comes to software development. So what's your best advice to folks about how to get ready for all this?
Like, if you look at software development, right, like there is a lot of hype and interest in AI today, but software development has always been similar to this, right? It has never been the case where you learn one thing and then you keep on working on it for next decade or so, right? Like, it's constantly evolving in terms of the framework, in terms of the architecture. We went from mainframe to PCs to data centers to, cloud, now hybrid cloud, AI, microservices, events, like this has been constantly evolving. So I think the advice is the same, right? Like it's about kind of constantly learning, understanding where you add the value, and I think in the end, be close to kind of the foundations, right? I think that's the hardest part, and that's where we add value. Yeah.
All right, folks, you heard it here. Hey, even in the age of AI, don't forget the fundamentals, because that's what's going to help you get through all this. Hey, Viren, thanks for being on the show.
Yeah, no worries. Thank you so much for having me here.
All right. And thank you all for listening to or watching the latest edition of the Cloud Native Now podcast. You can find this and other episodes on not just our website, but on Spotify, or Apple, or any place else that you listen to podcasts. Once again, we invite you to check out the entire library of podcasts that we have. And until then, we'll see you next time.